Good morning, friends. In the today's lecture, we are going to discuss the very important law in the physics, that is Ampere's law. Previous lecture we have studied about the Barrett and Savart law and its applications. After that, very important law we are going to discuss in the today's lecture, that is Ampere's law. In the Ampere's law, we have to discuss about what is the statement of Ampere's law. After that, mathematical statement of Ampere's law and differential form of Ampere's law. These three conditions we are going to discuss in this lecture. Now, what is the statement of Ampere's law? That is, first of all, we have to consider here the statement for the Ampere's law. That is, mathematically we have to say that a line integration of magnetic field or a magnetic induction B bar dot dl bar over a closed loop C, over a closed loop we have to consider here, and that is equals to mu 0 times I, where mu 0 is called as a permeability of the free space and I is called as a current flowing through the conductor. Now, in this case, we have to say that the line integration of magnetic field B bar around any closed path in the free space. Line integration of magnetic induction B bar around a closed path in any free space is equal to absolute permeability. This is called as what? Absolute permeability, mu 0 times the net steady current flowing, steady current enclosed by the path, and mathematically this is the statement for a what we have to say, that Ampere's law. Now, Ampere's law. Many times question may be asked on this multiple choice question is what we have to say, that the line integration of a magnetic field B bar over a closed magnetic induction over a closed loop is equals to mu 0 times, means permeability of the free space times the current flowing through the conductor is called as what? Ampere's law. Or another type of question may be asked on that, which of the following is the mathematical statement of the Ampere's law? That is, line integration of B bar dot dl bar is equals to mu 0 times I. This is called as a statement for the what we have to say, that Ampere's law, where B is a magnetic induction then dl is a small element, then mu 0 is equals to what we have to say, that 4 pi into 10 to the power minus 7 Newton per ampere square. It is Newton per ampere square is called as what? Permeability. Sometimes motion may be asked on that. Mu 0 is also called as what? Permeability of the free space. And then I is the current flowing through the conductor. Then another form we have to consider for the application of the Ampere's law, the magnetic field due to a long straight current carrying a wire. Due to long straight current carrying wire, B bar is equals to mu 0 I upon 2 pi r. Remember the formula, sometimes question may be asked on that. Find the magnetic field That is, we have to say that mu 0 is the permeability, I is the current, and 2 pi r is the circumference we have to consider for the closed loop. A steady current is flowing through the element. This is one of the application for the one of the application for the Ampere's law. Now, first of all, we have to consider here that is a differential form of Ampere's law. For a differential form of Ampere's law, we have to consider here. The first is a statement for the Ampere's law. That is line integration of V bar dot dl bar is equals to mu 0 times I. Equation number say 1. This is line integral of V bar dot dl bar is equals to mu 0 times I. Mu 0 is the permeability, I is the current, B is the magnetic induction, and dl is called as what? A small element of the length. And then I is current I in terms of current density can be given by J bar is equals to line integration of J is called as what? A current density, that is I is equals to J bar dot ds bar, surface integration of I is equals to surface integration of J bar dot ds bar. This is equation number say 2. Current density in terms of current flowing through the circuit is given by, that is surface integration over the closed surface J bar dot ds bar. Put in equation 1. What we have to get that? Line integration of B bar dot dl bar is equals to surface integration of J bar dot ds bar into what we have to say that mu 0 is there, mu 0 times J bar dot ds bar. Mu 0 is the permeability of the free space. This is the equation number say 3. Now converting line integral into the surface integral. By Stokes theorem. Stokes theorem, we have to consider, that is transforming or converting line integral into the surface integral by a Stokes theorem. What is the Stokes theorem? We have line integration of B bar dot dl bar is equals to surface integration of curl of B bar, surface integration of curl of B bar ds bar, equation number say 4. Now see the equation 3 and 4, what we have to say that left hand sides are similar. This is the line integral and the left side. We have to say that from equation 3 and 4. What we have to say that is surface integration of curl of B bar dot ds bar is equals to mu 0 times surface integration of J bar dot ds bar. Here surface integration can be vanished with the surface integration. Here this is the surface integration. Surface integration can be vanished with the surface integration. What will happen that therefore curl of B bar is equals to mu 0 times what we have to say that this is a mu 0 times j bar, and this is the differential form of a what we have to say that Ampere's circuital law. Differential form of the Ampere circuital law, that is curl of B bar is equals to mu 0 times j bar. This is the differential form. Differential form of Ampere's law. Many times question may be asked on that for which of the following is the differential form of Ampere's law, that is curl of B bar is equals to mu 0 times j bar. This is the differential form. Many questions we have to say that statement is what? The line integration of magnetic induction B bar over a closed loop C is equal to mu 0 times the current flowing through the conductor. Means we have to say that is called as Ampere's law. So this is sometimes we have to write that also. C is called as what? A line integration over a closed loop, and mu 0 is called as permeability. What is the value of mu 0? 4.10 to the power minus 7 Newton per ampere square. This is the value of mu 0, and that is called as what? Permeability. This is the formula for magnetic induction, and this one is called as a curl of B bar is equals to mu 0 times J bar is called as a what we have to say. This is called as a differential form of a Ampere's circuital law. Differential form of Ampere circuital law. This is very important. We have. I think write down all the things. Thank you.